Welcome back to the third session of Module 5. In this particular module, we are going to learn on study of topographic maps, contour maps, remote sensing concepts, applications of remote sensing, concepts of GIS, Geographic Information System, and GPS, Global Positioning System, and its resource mapping, overall application of remote sensing and GPS, especially with regard to civil engineering, particularly we are going to discuss. So before moving on those things, we must be in a position to understand what is meant by a topographic map, or generally what is meant by a map. A 3D view of converted into 2D view in a plane sheet which should have a definite of direction, specific scale, map number, and published year and legend. It's simple to say it's a 3D to 2D conversion, which means with the minimum things of no direction, specific scale, numbers. That is what we call it as a topo sheet, topographic maps. Generally, we use the word topo sheets. So, topographical maps, the map which represent both natural and man-made features with the difference in elevations. The differences between the highest and lowest elevation of an area will be shown by contour lines. So it represents the important natural and cultural features such as relief, vegetation, water bodies, cultivated lands, settlements, and transportation networks, etc. So if you're going to see this particular picture, you're in a position to understand what is meant by topo sheet. We have spread the number of topo sheets on the particularly on Indian map. So when we are going to talk about a particular thing, particular grids, we are divided the globe into different grids. In particular, we are talking about Indian topo sheets. So we are having different scales. If you are going to zoom this particular area 57, 57, so which comes to right, left, and all those things. So that is present in the so scales, that is to 10 lakh, that is to 1 lakh, that is to 50,000, that is to 2 lakh 50,000, that is to 50,000, that is to 25,000, that is to 5,000, one is to 1,000, one is to 5. So these are all the different scale. But generally, people are going to use much about 5,000, one is to 50,000, one is to 1 lakh, one is to 2 lakh 50,000 scale. So these are large, medium, and small scales. Okay, so these are all the different grids that are shown in this particular image. All these topo sheets are prepared by Survey of India SOI, which was established in 1769 and prepares the topographic maps of the entire country. These topographical maps are drawn in the form of series of maps employed by different same reference points, scales, projections, conventional signs, symbols, colors, the scale units of the different topographical maps are different scales are available as we have previously talked about. So reading of topographical maps, legend, conventional signs, symbols, sheets, marks. So these are all very important parts of topo sheets or maps. So what is meant by contour maps? How these contour maps plays an important role as far as civil engineers are concerned. It's the most important thing that you must know. Contours are the lines of equal elevation. These are all imaginary lines joining joining cases of having the same elevations above mean sea level. MSL means the mean sea level, showing the landforms. The method of showing the relief features through contours is a very useful and versatile in representing the topography as an area. During the recent years, aerial photography and remote sensing techniques have been replaced with traditional techniques of ground survey, leveling methods to draw the contour lines. Nowadays, we have recent technologies called remote sensing, GIS, GPS. So all these things are very important nowadays. If you are going to apply these tools into the civil engineering field, and the work will be very accurate, and we have a number of applications related to these. So contour maps are also available in different scales. So contours are drawn in different verticals like 20, 50, 100 meters above the mean sea level. So these are what we call it as a contour intervals. Vertical interval between the two successive contour lines remains constant, while the horizontal distance varies from place to place depending upon the nature of slope, what type of slope it is depends. The horizontal distance is also known as horizontal equivalent, that is HE, is the large when slope is gentle, okay, greater or reduces, decreases, something like that. So with increasing slope gradient, closely spaced contour represents steep slopes, while widely spaced contour represent gentle slope. With the values of gentle slope or slopes, we can identify whether it is a Dirac values. When two or more contours lines merge with each other, they represent the feature of vertical slopes, such as cliffs or water bodies. Two conditions of the two contours of the different elevations usually cross each other. So this is the most important point that we have to put it down. So here is a representative figure of different imaginary line. That is what we call as contours. So what are the uses of these contour maps or topographical maps? Topographical maps are integrated to design and plan of mega infrastructure projects such as railways, highways, water pipes, power lines. So we can plan that very accurately if you know about these topographical maps. In establishing of the telecom industries, the best locations are provided place to place where cellular towers, which is the where we have to put these towers at the greater elevations. So this is a very useful thing. In case of military, the same topographical maps are used to determine the strategic location to construct watchtowers being visible hostile armies. While construction dams, topography plays a really very important role deciding the dam location, dam catchment, as well as the submergence area. So topography, along with duration of time, soil types, slopes, categories, very much useful at determining the landslide susceptibility in the heat towns. Topographic maps can also be perform flood analysis since the natural water flows in the terrain. It depends upon the gradient, particular gradients. So topographical maps plays a crucial role in soil conservation and its planning during any hazards, whether it is a man-made crisis, emergency planners. So they are having this type of maps, topographical maps, to determine the safest location to relocate the affected people. In which area we have to reallocate these people which are affected by these floods, hazards, whatever it is. So these topographical maps are also used to determine the annual rooftop solar potential buildings in a particular city. So these topograph maps are wonderful tools to navigate and explore unknown terrains, unknown areas, and mountain regions. So these are all some of the useful things, usefulness of this particular photo sheet or topographical maps. Okay. So let us move on to remote sensing. So remote sensing, as the name itself indicates, anything which is going to sense at a distance without being into the physical contact of any of the objects or such. That is what it is written as the art and science of obtaining information about the Earth's object without any physical contact. That is most important thing. If you see this figure, here the main source is your sun. So from the sun, the source which is coming from the sun and it is hitting the particular area of the ground, it is reflected back, refracted, absorbed. All the totally TAR, total internal reflection, all these things happen. So this is the process where in the incident rays, we absorb, reflected, and refracted back. So this reflected energy will be stored, that means recorded from the satellite imageries. From that, so different bodies behave differently. If we are going to talk about the water bodies, if it is a shallow water body, it behaves differently. If it is a deep water body, it behaves differently. When incident rate absorbed, reflected, and refracted, there is a percentage. That is what we call it as spectral signature of any of the objects. Different objects have different spectral signature values. Depending upon the spectral signature values, we are going to assess what is that particular object which is going on the surface of the Earth. So these spectral signature values are being recorded on the satellite imagery so that what this particular object can be identified. Here, the natural light, we have a different type of remote sensing, active type of remote sensing and passive type of remote sensing. In active type, we are going to use artificial resource uh, for projecting the light and reflecting back all those things. Where sound will be used and artificial light, solar energy. So anything which is artificially used, that is what we call as active type of remote sensing. In passive type of remote sensing, sun is acting as a passive type of remote sensing, where sun itself is acting as a source of light or coming up the natural light, which is sun, these atmospheric elements, cloud, surface features, satellite sensors, geoprocessing. So if you look at this picture, you're in a position to understand what might be the concept of remote sensing in a simple form. So here the energy source, that is A, sun is the main source, and radiation from the atmosphere, that is EMR, electromagnetic radiation, which is going to interact with the atmospheric elements by traveling from source to target, source to target. Okay, source is the main sun, and target is whatever the object which is going to fall on the surface of the earth. That is what we have as a target. Here, electromagnetic energy, which plays an important role and is going to interact with the surface of the object, which is laying on the surface of the Earth. Interaction with the target. That whatever the radiation that is not absorbed or scattered in the atmosphere can reach the interact with the Earth surface. Different objects return different amount of energy depending on the physical, chemical, and optical properties of that particular object. Next point, what we are going to talk about is recording of energy by the sensors. Okay, A, B, C, D, among the D. After the energy has been scattered or emitted from the target, the reflected wavelength will be collected and that will be recorded through sensors. We need a platform to record that is what we call the sensors. Through sensors, all these things will be recorded. The error may occur during the data collection due to difference in the surface roughness, okay, angle of incidence, intensity, and wavelength of radiant energy. So these are all the points to be taken into consideration as well as ABCD points are concerned. Next big point is E, transmission, reception, and processing. The energy recorded by the sensors will be they are going to transmit the data that electronic form nearest observation station. Then it is we are going to detect the discrimination of that feature will be done in the final stage. The final form of the stage we are going to detect. The last one is interpretation and analysis. Later, the processed image will be interpreted visually and digitally extracted specific information from that particular object. So that is also very important whether what type of object it is. It also depends upon the person who is going to interpret that information. That is also plays an important role. So what are the different applications in this particular field? What we are talking about human sense? Geology is also having a very great role understanding the geological structural mapping. This is most useful, powerful tool in understanding the structural and geological map. Hydrology, mapping of the surface water bodies, monitoring the wetlands, snow cover, glacier. Totally, the water hydrology means which is related to water. Hydro means water, logy means study. So anything which is related to hydrological aspects can be studied in a well manner with the use of this particular tool, what we call it as sensors. Agriculture, in this particular field, crop type, crop rotation, its condition, analysis, soil moisture measurement, all these things can be understood in a very systematic manner. That is what we call as agriculture application. Forestry, mapping of the exact whatever the boundaries, biomass, estimation of species, identification, fire scale mapping. So these are all the things. Fire estimations can also be understood using the thermal bands. We are having different bands. So from if you are going to activate, we are going to trigger that particular band means we are going to get information related to thermal activities. Oceanography, sea ice identification, postal wind fields, waves, slopes, measurements. So in the field of oceanography means it's study of oceans. We are going to have a lot of applications related to remote sensing. Shipping, navigation in types of ships, detection, classification, coastal zones identification, shoreline detection, fresh sea water interaction. There is a lot of interaction between the freshwater and seawater interaction. In general, vegetation cover, how much is the percentage of vegetation cover in that particular area, can also be identified. Military security applications, detecting the exact location of the speed, the warplanes can also be identified. So every subject has its own limitations. So let us know what are the different limitations of this particular remote sensing what we are talking about. Remote sensing is fairly expensive method of analysis, especially when measuring the smaller areas. Requires a special kind of training, a special kind of training is required for effective interpretation of remote sensing technology. It's a very expensive to analyze and repetitive photographs are required. Instrumental errors may lead to an uncalibrated remote sensing data. That is also that we have to take care. The information provided by remote sensing data may not be complete and may be temporarily have to visit the field sometimes. Large scale engineering maps can be prepared for satellite data, which make remote sensing data collection incomplete. So all these things are not to take care. Let us move on to the further one, that is what we call it as GIS, Geographic Information System. So the system we are going to have is a computer-based software using for mapping, analyzing, storing, displaying, and managing all type of geographical data. Okay? This provides solution to real-world problems, and and it helps actually. It helps, and it is going to help aerial photographs for the future generation, extract useful information from the digital aerial photographs, satellite images, global positioning systems, these data, what we are talking about, GPS, along with the tabular data informations, graphic locations, graphic that means the exact location of the land and water. Information can be associated with a place or name, stream, address, so anything can be maintained. It's all government bodies require geographic information system. At least 70% of the all the information used by the local government, especially the geographical, there should be geographically referred. So we are having different components of GIS. So hardware, software are the very important things. So here hardware is a consists of equipments as you know the supporting device that are required to capture, store, process, visualize in the geographic information system. So these includes computers, hardware, disk, digitizers, scanners, printers, plotters, etc. So these are all the hardware components of the system. So next one is software. Software is a main part of the GIS system. The GIS software must be having the basic capabilities of the data input, storage, transformation, analysis, and providing desired outputs, which are different using different softwares. So we are having different softwares. ArcGIS, this is the ISRI. So widely spread, properly used GIS softwares. Other categories are ERDAS imaging, NE, Surfer, Geomatica, Rockware. Freely software available also, we can get it through the net. It is what we call it as QGIS, Class, Map, Windows. So we are having different type of software available. So another component is data. So if you are going to put good data only, then you are going to get a better data. If garbage in, garbage out, concentration, work out. So the data is collected from the various sources such as survey maps, field observations, aerial photographs, satellite images, which are required for analysis of extraction. So we are having different procedures. So these include methods and tools by which data has been input system, retrieved, processed, transferred, and presented in a presentable format. So people, the component will make GIS work for easy accessible program, database managers, GIS researchers, and
also individual who are the end users of GA service applications and tools. The people are very important thing because so depending upon the requirement of the requires, so how we are going to provide those services to the companies and all those things that we have to take care as far as people are concerned. Totally, these are the different components. This is a picture of representation. JS components, softwares, hardware, data, people, and method. What are the different methods we are going to use? So it's the on the left hand side, if you're going to see the real world. So JS is going to provide different platform that is we have generated. We have done a thematic map of imagery, elevation, transportation, addresses, boundaries, water features, survey controls, your data. So these are all the information which we got from the real world through the remote sensing concept and using the different best data. So those things are applied over here in this JS platform to get all these things. Different thematic layers, what we want. So use of GIS handles much larger database into simple formats. So GIS can be associated with name, stage, address, zip codes, latitude and longitudes. 70% of all the information used by the government is geographically referred. Extraction of natural resource management to the maps, infrastructure transportation management, economic development and planning is most important. Health and public safety during the fire or major accidents. We have to take care, can use this. Locations of the soil types, coastal management, measurements of the straight lines in areas. When we generate a buffer, we can buffer a zone when we are extending the roads, we can have a buffer zone of 0.500 meters, 200 meters, 300 meters, something. So let us move on to the next concept that is what we call as a GPS. GPS means global positioning system. From that, we are going to have accurate location of yourself or where the instrument is being worked. Okay. We are having space segment, control segment, and user segment. Okay. Here, so the basic principles of GIS works on these. That is space segment, control segment, and user segment. So among these space segment, it has having 24-hour service in all the weather conditions, analyzing up to 24 satellites orbiting at an altitude of 20,000 kilometers. Satellites orbits are 12 hours. Six orbital planes are inclined at an angle of 55 degrees with an equator. Constellation provides 5 8 satellite vehicle from any point on the Earth. Next one is control segment. It has three components: monitor station, master station, and upload station. It accumulates ranging data from the navigation segment, which transport the data into receiver located in US. Master control station, the data collected by this segment provides a real-time information with gravity, field, influencing the satellite motion. Third one is upload station. This data will be loaded into satellite memory for a specific data shared through parabolic antennas, transmitters, computers. They measure the distance of the overhead satellites every 1.5 seconds and send it to correct it to master control station. User segment. This user equipment consists of the antenna, receivers, data, and display units. So, what are the different applications of this? So, most useful in government, private, survey agencies, projects. So, helps to produce more accurate and reliable data, produce much faster in a conventional survey methods. So, mapping techniques are very easy. Reduces the amount of equipment and labor required. So we can do at a faster rate. Accurate mapping and modeling and mountain ranges, rivers, streets, buildings, whatever you want to do. GPA with sonar can predict underground hazards, underwater hazards. So bridge builders, offshore oil rigs also depends on the GPS for accurate hydrographic surveys. Conservation of soil, land, and water using the GIS can assist the strategy of planning. So GPS and their use in resource mapping. So mapping the exact boundaries of the land features can be done using GPS, and the same can be displayed on the maps through GIS tools. GPS is especially useful in surveying coastal water flows directions, whereas the few land portions are also reference points. So GPS positions with sonar depth sounding to create a nautical charts. One nautical is 0.852 kilometers. That alerts mariners to change the water depths and underwater hazards. Which builders offshore rigs depends upon the GPS accuracy on hydrographic surveys. The surveying and mapping community was also one of the first to take the advantage of GPS to increase its accuracy to produce more reliable data. Today, GPS is a vital part of the surveying mapping activities under different conditions. These are where different skilled professionals also in this particular field. So GPS based on the data collection much faster than the conventional surveying methods what we are using in earlier days in order to reduce the equipment and labor requirements. A single surveyor can now accomplish in one day that the entire team of surveyors. So this one to reduce the manpower which is required. So after understanding all these things in this particular session, we are covering remote sensing, GIS, GPS concepts and its applications and what are the limitations of this under course objective CO5. We have covered some of the points. So with this knowledge of remote sensing, GIS, GPS, being a civil engineer, you must be very intelligent to apply this knowledge in your fields so that it can be a better option in understanding the concepts, the basics of remote sensing, GIS, GPS, in applying different fields of civil engineering field. So that makes the really a big difference and it's a challenging task also.
So with all these questions, we will go to some of the multiple choice questions. So which of the following is not a principle of remote sensing? We are having the options A. Interaction of energy with satellite. Electromagnetic energy, option B. Option C. Electromagnetic spectrum. Option D. Interaction of energy with atmosphere. So question number 2. Which of the following field is used by EM waves? Solar energy, polarized field, electric field, microfield. Third question, which of the following is not a classification of scattering principle? Faraday scattering, Rayleigh scattering, Mu scattering, non-selective scattering. We have different type of scattering. You have to select the best of that answer. So which of the following cannot can act as an example of airborne platform? List 3, Dakota, Moss, list 2. You have to identify which is the correct one. Contour can be found in dash maps, political maps, topographical map, physical maps, thematic maps. Next one is contour maps are not mandatory in civil engineering projects like road works, dams, channels, etc. Whether this statement is true or false, you have to identify that. Next one is GIS stands for Geographic Information System, Generic Information System, Geological Information System, Geographic Information Sharing. So you have to identify the correct answer in that. Next question, GIS deals with which kind of data? Numeric data, binary data, spatial data, and complex data. So with all these questions, you are in the end of the session 3. Thank you. We will meet in the next session. Thank you. Thank you very much.